Hello everyone, I'm Jason Sikes, aka the Tech Rancher, and this is my homework solution for lesson number 25. The course is by Paul McWhorter. It's called Raspberry Pi Pico W. Paul does multiple different types of courses for electronic engineering. You can check him out on YouTube at Paul McWhorter or on his Facebook page at www.toptechboy.com. Let him know that I sent you. It would mean a lot to me. Alright, enough talking about Paul. Let's get to what the homework assignment was. The homework assignment was, and let me pull that up here. I'll show you what the homework assignment was. I just think that would be better than me trying to explain it. And go around here and hit this, and as you can see over here on the screen, it's a circle. Wow, my circle. That's pretty darn nifty, isn't it? Boy, I have to admit, I spent the first afternoon after watching that video writing on notebook paper, thinking, how am I going to plot out a circle? Paul was teaching us how to make these plots, how am I going to plot this out? He was teaching us how to do pixels, and there's just got to be a way you can probably just take a circle and just put the pixels around right where the arc of the circle would be, and then well, why not? So I looked online for some graphing paper, and let me just pull it up here if I can find what I did with that. And here we go. And let me go to that here, and let me just minimize this guy. Oops, wrong one. There we go. All right. So yeah, I got graphing paper, and I made me a circle, and I made me my radii. So I said, perfect, man. I'm gonna do this. I'm gonna figure this out. So then I kind of had enough understanding of getting the little dots that you're gonna have to come over on the X and go up on the Y to get it. And then I thought, well, you're gonna have to do this 360 degrees around, to figure out each one of these little dots going around here. And just thought, okay, so I made a line, and I was trying to represent that line's gonna be a certain distance, and I was just scratching my head, which I don't have very much hair to pull out to try to think about that, but I just kept on, okay, there's just got to be a way how you could do this, but I didn't have a formula, and I was just trying to come up with it and trying to wing at it, and so the next day when I had some free time, I went back at it here, and I looked at my graphing paper, and just kept on wondering, so finally I was like, all right, I'm just going to try to figure out how to plot that. I'm just going to have to go over X a certain amount and go up a certain amount, and then just realize that that's going to be my first, and I'll make it 1 degree, and that'll be my first one little degree, and I'll make a dot, a pixel dot there. Well, come on, folks. When you really start thinking about that, that's going to be a lot of dots and a big amount of coding to try to do. Because I didn't really understand the formula to try to make it into a function to do a loop. So I cheated. I went and looked around online and found on Khan Academy here. It had a formula. That's what I would need, a formula. And for a semicircle here, and it was given the arc of a semicircle. And I thought, well, if it's doing an arc of a semicircle and it's got a formula for it, I bet I can figure it out. So I took this formula right here, y equals the square root of 1 minus x to the square. Let me break that down real quick for you. The square root of 1 represents our radii, and minus x would be our x coordinates on the plane, the horizontal plane, and it's squared. So then I was like, okay, I can understand that. I got something. I can be able to run with this. And so I spent the weekend trial and error. And you can see I did a little fancy things on the side too, written around here, other than just going ahead and working on this function here. But I kept motivated on it and kept on working, and I finally figured out a little bit of a loop going on here, enough that we started making some dots, and it started making these dots into a circle, and yes, I got it going. And so as you look here, let me kind of break this down here. In our arguments, and called it the circle, we're bringing in x and y coordinates, which Paul gave us those x and y coordinates. He said put it in the center of our display. Well, it's 128 by 64. So you just take that by half for both of those and you got the center mark. Okay, and then he gave us the radius, and the radius was 20. So I gave that as an R for my argument, and then color would be to say on or off, like the pixel required for either to turn it on or turn it off. So I threw that argument in there too. So then I thought, well, you're going to have to for loop it. You're going to have to for loop it to be able to continue to do these dots, because I tried first time putting the dots in myself after I got about to 20 lines, and it barely made a couple, well, barely a little radii, circumference area. I thought this is ridiculous. So then I thought, okay, I'm going to have to make a for loop, and we're going to do a range. And so I started thinking, how are we going to do this range? We're going to figure out the range of it. And then I started thinking, just like I did with the graph, we're going to do triangles. We're going to have to do the triangles, and it's going to have to take that many triangles to start making the arch. Because I was going to do half and half. That's why we have two, the two for loops here. And to be able to combine it together. And the first half is our y's, and our second half is our x's. Y's we already got in our pixel in here, because if you look at our pixels, the first argument is for x, the second argument is y, and the third argument is for to turn it on or off in a pixel. And so I started my first set of my arc with knowing x, and the second range of the arc was to figure out the formula for y. And so so in my range, that's what I had to set up. I set up with, we know x and we know the radii, so we needed to minus that to get to our first set of our range. And then we take x, because we know that again, and we know our radii, and we have to go by 1 according to what I read on Khan Academy to be able to do our line, to be able to get our dot. And so this is being able to calculate for a right triangle being converted around into getting our dots. And so this is our known x, and this one would be our known y for this for loop. I'm going to try to go to the quick because this is getting long here, but the first one is the argument. We got this by going through our for loop, and we displace that in our pixel. And then our second one is doing the math. We take y minus the square root of the power of r, so we're taking r squared, or r to the power of 2, so we're taking r plus r, or r times r, and then x minus the value of the first I, and then times x minus the value of the first I again. I try to do that in a formula with Python. I try to put it into power of x squared and to minus I, and it wouldn't work, and I even tried to put it in my scientific calculator, just that formula of trying to get x squared, because that's what was a formula that we saw for the Khan Academy, was y equals the square root of 1 minus x squared. So that's what I knew. I had to get x squared in here. Python wasn't taking it. The MicroPython in this was not taking it, so I had to write it out in the form that you're seeing here, which is x minus I times x minus I. Adding the color in to be able to say turn on that pixel. Ran it through the loop of the negative first, and then the positive y. So give it our half arc and another half arc of going up the y scale. Up and then minus. And then we had to do the negative and then the positive and negative of x's to get the same, to be able to get our right triangle for our dots. This is not the best formula. I probably know it's, I'm sure there's a different formula, and I'm sure Paul on the next homework or in the next video is going to show even a better one. It probably doesn't require this much brain thinking and trial and error. And it did, as you can see here, let me pull that camera back up, it does not do very good on the horizontal, as you can see on the horizontal sides, where the X is, it's just barely coming off the X. It doesn't hardly have any dots at all. But as you continue to go on around the circle, the farther you get to the 90-degree angle top, it does continue to have it. I tried after about 4 days of just playing with this and realized I'm getting really behind and trying to get caught up with everyone else. I just had to submit what I got and go on. So there you go. I got that, and during my trial and errors and frustrations, I started playing around with graphics on this. And so, a little example here. Oh, and I brought the circle down. I didn't like the circle where it was at. So this is my next file, and I brought the circle down, and I made some graphics. I'm going to do a video on this because I'm sure other people are wanting to learn how to do graphics. And since I took the time of frustration of having to take a break from trying to figure out a circle, I learned how to bring in a graphic. First, you had to convert it over into a byte array, and then you had to be able to open up that folder. And first, you have to put it on the Pico W, and I had to learn how to do that on the Visual Code Studios compared to Thonny. Thonny is really simple, but I'm liking more the Visual Studio Code of what's there, the IntelliSense and the different things that it provides for Python. And I've done it for about 3 years now, played with Python. I've done a lot of back-end coding for websites and take care of different churches' websites and doing the back-end parts. I'm not graphical. Being partially colorblind, I'm not good at design, but I can figure out the back-end coding, and I can do different things for the databases. And so I've always used a Visual Studio Code. Excuse me. So I figured out how to access my Raspberry Pi Pico W on the side and be able to drag and drop in. You can see where I had to drop in the image here to be able to get that, but I'll show that in the next video. This is getting really long for homework solution, but please leave some comments. And oh, I'm sorry guys, you can't even see what I was doing. I did that earlier here. Sorry. Okay. Raspberry Pi Pico W. Right. What I did right over here is I figured out how to access the Raspberry Pi Pico W to drag and drop in files and make folders without using Thonny. But all right, like I said, I'm gonna make a video for showing graphics for that. Please leave some comments. Like I said, they help you. They either if they're just nonsense, you push them to the side, or yeah, I know that. Thanks for giving me the time of commenting to me, or wow, that's good information. I'm open to that. That's the only way you get better, sharpen swords, as you say. So leave a comment. Until next time, everyone be safe out there. We'll see ya.